Okay, this section is about breaking apart a right triangle if you draw an altitude to the hypotenuse. This is called the altitude to the hypotenuse. You're going to get two triangles that are smaller and then one large one. So the big triangle has the short side of A, a long side of E, and the hypotenuse is B plus D. The medium triangle is this one. The medium triangle has a hypotenuse of E, a long side of D, and a short side of C. And the small triangle is this one right here. So you should be able to take a figure like this where the altitude is drawn to the hypotenuse. So C is the altitude, and then draw three different triangles. All three of these triangles are similar. So then you can write E is to A as D is to C, D is to C as C is to B. There's so many different proportions that you can write. That's the first part. The second part is the geometric mean. So the geometric mean is if you have two numbers, A and B, and you're trying to find the number that's in between them, and it's this is a geometric sequence, you're going to take the square root of A times B. So it works like this. So if you're going to use the cross product property and say AB equals x squared, x equals the square root of AB. We also talked about, in order to do the geometric mean, we have to reduce square roots. So I'm just going to do a couple examples because we did this in class before. But the square root of 72 you can break down into 36 and 2, 6 and 6, and 2, 3, 2, 3. So it's the square root of, you circle all of the primes. So there are 3 2's and 2 3's, and you take them out in groups of 2. So you're going to have a 3 and a 2 on the outside, so it's going to be 6. 3 times 2 is 6, and you have a 2 on the inside. The square root of 40 is, factor out 40, 4 and 10, 2 and 2, 5 and 2. So you have 2, 2, 2, 5. Take out one group of 2, and on the inside you have a 10. 5 times 2 is 10. Okay, so going back to the triangles. Solve for the missing variables in each. What you want to do is draw out a small triangle, the medium triangle, and the largest triangle. And make sure you're labeling the right angles in the right spot. So the small triangle is this one right here. So the short side is 2, the long side is 6, and nothing is labeled for the hypotenuse. The medium triangle is this one. The short side is 6, so I'm going to write the short side is 6. The long side is x, and the hypotenuse is y. And then for the largest triangle on the outside, the short side we don't have, the long side is y, and the hypotenuse is x plus 2. Okay, so if you're trying to solve for x and y, what you want to do is set up a proportion so that you only have one variable. So if I wanted to solve for y, I wouldn't do y is to x as x plus 2 is to y. I wouldn't want to do that. I wouldn't want to do y is to this thing because I don't know what this is, unless really you can do the Pythagorean theorem if you want. You can always do the Pythagorean theorem. But if I'm going to solve for y, what I'm going to use, or I'm actually going to solve for x first, because I can see I can do this proportion right here. So x is to 6 as 6 is to 2. So I cross multiply and get 2x equals 36, x equals 18. So I write 18 right here. which makes this one right here 20. If x is 18, then that's expression's 20. So now there's a couple ways I can find y. So I could do y is to 18 as 20 is to y. I'm going to do that one. So y is to 18 as 20 is to y. And then I do cross multiply. And if I know that I'm going to take the square root of 18 and 20, I'm already going to factor out 18 as 3 times 2 times 2, and 20 is 2 times 2 times 5. So I take out a 2, take out another 2, 15 inside. So y equals the square root of 4 root 15. Since we're talking about distances, I'm solving for y squared, but I'm not going to put a negative as an answer because I'm talking about a distance. And then number 2, I'm going to set up the 3 triangles. So we have a small triangle right here. The short side is x, the long side we don't know, and then the hypotenuse is y. We have a medium triangle where the short side is we don't have anything labeled. The long side is 192 and the hypotenuse is 240. And then we have the big triangle, which is the short side is y, the long side is 240, and the hypotenuse is x plus 192. Okay, so you have 3 different triangles that you can go off to try to solve one of the variables and not have another variable in the equation. So I would do this proportion for x. I would do the proportion as x plus 192 is to 240 as 240 is to 192. So I would do these two right here. Once I have what x is, plug x back in right here and right here, and then you can use that to solve for y. You could also use this, if I plugged x back in right here, I could also use the Pythagorean theorem to solve for y. What other way that you think is easier? Okay, here's some more. So I'm going to set them up and explain how I would do it. So here's a short side. This one is a small triangle, 5 long side x. The medium triangle has a short side of x and a long side of 15, and a hypotenuse that we don't know. And then the largest triangle has a hypotenuse of 20, and then the short side and the long side are not labeled. So I'm not going to use this triangle. So in this one I'm trying to find the altitude. Right here, I'm going to use this proportion. So I'm going to do x is to 5 as 15 is to x. So x is to 5 as 15 equals 15 is to x. And you can cross multiply. Okay, the next one I'm going to draw the small triangle. The hypotenuse is 15 and the short side is x. Then the medium triangle. The hypotenuse is 20 and the long side is y. And then the large triangle. The hypotenuse is x plus y. The short side's 15 and the long side's 20. Okay. So this one you have to think about, I'm trying to figure out how to solve for x or y, but my proportion can only have x or a y. I can't do both. So for example, I couldn't do 20 is to x plus y as y is to 20 because I have x and y. I also don't want to do x plus y is to 15 as 15 is to x because I have x and y. So I need to find a triangle that I can use that just has one variable in it. So I'm going to do these two right here. Put these in blue. Okay, number 5, we draw out 3 triangles. So the small one is, we don't have enough information. There's not enough right here. So it's not x, because x is all the way across, so I'm going to leave that blank right now. And this is y. And then the hypotenuse is 28. And then the short side on the medium one is y, and the hypotenuse is 28. And then the largest one has the short side 28, the long side 28, and then the hypotenuse is x. So for this one, I would use the Pythagorean theorem. So 28 squared plus 28 squared equals x squared. And we do that, x equals the square root of 28 root 2. So then after that, I would use this triangle. 28 is to y as 28 root 2 is to 28. And I would cross multiply and solve for y. And then number 6, find the geometric mean. So geometric mean is you're going to multiply these two numbers and take the square root of it. So before you multiply it and then factor, I think it's easier just to factor each number out separately. Oops, I wrote 5. I wrote 5 times. I meant to write 2 5 times. 2, 2, 2, 2, 2 times 2. Because this 2 and this is 32. So you take them out in groups. All of them have a partner, so 2 times 2 times 2 is 8. So geometric mean is 8. And then the geometric mean of 6 and 20 is factor out 6 is 3 times 2. Factor out 20 is 2 times 2 times 5. Take this out for a group, so you have 2 times 3 is 6 times 5 is 30. So it's 2 root 30.